Hi everybody, welcome to physics. So today we just have a short little slideshow to go through, okay? So first we're going to start with electrical power, and we did see this in the past, again a week ago, but here are our formulas, so make sure you have these on your formula sheet. So P equals W over delta T, and that is the exact same thing as P equals delta E over delta T. So work equals the change in energy. So W equals delta T, or delta E, sorry. Okay, so in a circuit, the loads, light bulb, resistor, motor transform electrical potential energy into heat, light, motion, sound, or other forms of energy. So that's just what it's saying, okay, that's what that power is. So here's a derivation for three more important formulas. Now, the derivation is not very important if you want to take a look at it and try to see where everything is from. Like you can see voltage and then how the voltage, like the change in energy over here. Like I said, not too important to know the derivation, just so if you can try to follow it, that's great. But have these three formulas on your formula sheet. Now, there's a little bit of misconception in the world that power is energy. So often you hear people speaking and saying like they're buying power from the power company. But if you check your electric bill, so for us that would be Maritime Electric, it's actually charged for energy. So it's measured in kilowatt hours. And that's what consumes. So power measures how fast you do the work, not how much work you do. So it's electric energy that keeps your lights on, right? So it's energy that we're buying. So you can see the conversion down here of what 1 kilowatt hours equals in joules, which is the form of energy, okay? And next up is just an electricity bill from Maritime Electric. Not overly important. It's just going to show you certain things to look for, like our kilowatts per hour or kilowatt hours used. It's showing you how much per month a service charge is. Right here, we wrote out how much it was in the first block. So it was $14.92 per kilowatt hours. And the second block was $11.88 per kilowatt hours. Right, so just a little bit of information there. Okay, because that's what we would normally see from an like a power company coming to us. This is how we would see it. Now we just have a model problem here on page 745. So a family has its television set on for an average of 4 hours per day. If the television set is rated at 80 watts and energy costs $0.1492 per kilowatt hours, how much would it cost to operate the set for 30 days? So over here we wrote out what's given, changed your power from watts to kilowatts. We have the dollars amount of what it costs per kilowatt hours. Time, change it into hours. Okay, so we're going to use our P equals delta E over T formula. So P equals work, or change in energy over time. We're solving. It wants to know how much it would cost to operate for 30 days, but we're solving for the change in energy. Okay, so just plug that in. And then at the end, we know our energy, but we need to know how much it costs. So we come back up, find how much money we're using. So we just times those, cancel out the units. So $1.43. Okay, so we have a few questions for homework today. Give those a try. Posted the answer key online as well. Let me know if you have any questions. Email me or join the Google Meet. Have a good day.